So now we're going to take a look at functions. I've got a few definitions for you. First of all, what a function is. A function is a set of ordered pairs in which no two different ordered pairs have the same first coordinate. And bottom line, what that means is there's no repeating x values. Okay, and then the domain is the set of all inputs, in other words, it's x's. The range is the set of all outputs, in other words, the y's. And the way that you remember that is it's alphabetical order, x, y, domain, range. So alphabetical order. Okay, and then a relation is a set of ordered pairs. And of course, we're not talking about grouped fruit here. I know it's a sad joke, but ordered pairs are something that looks like this. We usually have a bracket, and then we have ordered pairs of numbers like 1, 2, -7, 5, and as many other coordinates in there as possible, or whatever, and we have our brackets around it, and that is a relation, an ordered pair. The next thing that we'll do is the vertical line test, and all I'll put on this slide is that it checks for a function, checks graph for being a function. And finally, function notation. And what this is it uses function notation f of x. F of x is y. And that means whenever I write an equation, if I was to write y equals mx plus b, I could replace the y with f of x. So that's all that is, function notation. And now what we're going to do is graph a relation. A relation is just a group of ordered pairs. And so all we do is plot them on the graph. So plot each one, -2, 4. So 1, 2, 1, 2, 3, 4, draw a dot. And then you go to 3, -2. So you go right 3, 1, 2, 3, down 2. And that's the second one. -1, 0, dot right there, and then 1, 5. So one more higher, and right there. So that is my relation. I've graphed it. So you're plotting points. It's not a complicated thing. The domain is a set of all x's, so all you have to do is write all the x's, and that would be -2, 3, -1, and 1. And then the range is the set of the y's, and so you just write 4, -2, 0, 5. Now let's say I had one more point up here. Let's say I had 1, 3. Okay? On the graph, I would go over 1 up 3. Okay? Now, when I write the domain and the range, I would go ahead and put the 3 down with the y, but I don't add another 1. You only write each number once. Okay, so that's how when you're writing the domain and the range. Now usually they use brackets here, by the way, so I would have put brackets around that to make that. That was a terrible bracket. Let's try it again. -2, 3, -1, 1, and then we would have closed brackets. Generally, that's how you end up writing your domain, is with brackets around it. So now we're going to work on what's called a mapping diagram. What a mapping diagram does is it takes your domain and your range and writes them in vertical columns. And I write each number only once, so I have -1, 3, -5, and 3 again, but I only write it one time. And then I write my range. I have -2, 6, -10, and 2. And then what you do, the mapping diagram, it just draws lines from each x value to the y values that they go together with. So -1, you draw a line to -2, and you actually draw an arrow. It gives it direction. You go from the x to the y. So from the x to the y. And then the 3 goes to the 6, and it also goes to the 2. And finally, my 5 goes to the -10. So it's kind of like in elementary school where you did matching. You're just drawing the arrows for which number goes to which corresponding number. Now, what you were going to be able to do is look at a mapping diagram like this one and say that it is not a function. This one is not a function because it has x repeats. The one that's a problem in particular is this 3 right here because it has 2 lines coming from it. If it only had 1 line coming from it, then it would be a function, but it doesn't. It has 2, so this is not a function. Now here's another one. Let's say I had -2 going to the 3, 0 going to the -1, and 5 going to the 4. I could look at this mapping diagram and I could say this is a function. Because there are no x repeats. Even though lines are crossing, that's okay. There's no repeaters. Now, let's try it again. And if I had the -2 go into the 3, and it went to the 4, 0 went to the -1, and 5 went to 3. Now, this is a problem because, as you can see, 2 has a repeat. It goes to 2 different places, so this is not a function. Okay. Now, let's say I had one more x value here, like 10. And then I had things going like this. Now, the scary thing is that this 3 has 2 lines going to it, but that's not a problem. This still is a function because there are no repeating x values. The y can repeat, that's not a problem. It's the x value that can't repeat, so this is a function. Okay, and so again, this is a very similar example. This again would be a function because I can have y values repeat, but not x values repeat. So this is a function. So it works.